Hello everyone. In this lecture, we will discuss about the solution to wave equation, that is the Bloch function, as well as about the Bloch's theorem. The Bloch's theorem is just a way to describe the wave function for a periodic solid. We know that solid is periodic at atomic scale, so that the Bloch's theorem explains how the wave function and energy are constrained for a periodic solid. So it has got two postulates. The first postulate states that the eigen function of wave equation, that is the wave function, for a periodic potential are product of plane wave, that is e raised to ik dot r as in free electron model, times a function uk of r with periodicity of the crystal lattice. That is, since we have a solid that is periodic in the atomic scale, we get a traveling wave solution for psi that is modulated by translation symmetry of the lattice, that is uk of r. Mathematically, we can represent psi k of r is equal to uk of r times e raised to ik dot r, where this uk of r, the modulated function, has period of the crystal lattice, that is uk of r is equal to uk of r plus t. That is, the traveling wave solution must suggest that we must have periodic boundary condition for the microscopic solid. Alternatively, there is another postulate using this theorem. That is, we can describe the wave function as psi k of r plus t is equal to an operator c times psi k of r. That is, we can say that the wave function at r plus t, that is translated by one unit cell, is very related to the previous wave function, that is psi k of r, using the operator c. So the c is an operator that translates the wave by one unit cell. With the periodic boundary conditions, if we apply c n times, where n is the number of unit cell, we get back to the original wave. By replacing r with r plus t in the first postulate, we will get psi k of r plus t is equal to uk of r plus t times e raised to ik dot r plus t. Since uk of r is equal to uk of r plus t, we can rewrite this above equation as psi k of r plus t is equal to uk of r e raised to ik dot r plus t. Again, using the first postulate, we can substitute for uk r, so that you will get psi k of r plus t is equal to psi k of r divided by e raised to ik dot r times e raised to ik dot r plus t, and that is equal to psi k of r times e raised to ik dot t. That is, from cell to cell, the wave function varies by a phase factor of e raised to ik dot t, where t is the translational vector. So that is all the Bloch's theorem does is connect the wave function of the solid to terms of underlying translational symmetry. Now we'll discuss the physical interpretation of the Bloch's theorem. We see that the wave function is periodic at two length scales, where the modulation function u is periodic in t, that is the atomic scale, with lattice spacing a, and e raised to ik dot r is periodic in L, that is the sample scale. On multiplying the real part of u with real part of e raised to ik dot r, we can see the real part of psi, the wave function, the modulated function. So that is the Bloch wave is shown in this figure. So this is how the real part of wave function look like, and that is called the Bloch wave. We will discuss about the restatement or the exact proof of the Bloch's theorem, which is even applicable to the degenerate wave functions, that is the energy eigen function having different values of eigenvalues. In the derivation of wave equation, we see that the wave function psi of x can be expressed as a Fourier series summed over all the values of wave vector permitted by the boundary conditions. That is, psi k of x can be expressed as is equal to summation over k ck e raised to ik dot x. Since the coefficients ck are now related only to those coefficient which is shifted by g, that is what we derived during the wave equation or the central equation, we can rewrite the wave function at a particular wave vector at the atomic scale. That is, psi k of x is equal to summation over g ck minus g e raised to I k minus g dot x. That is equal to summation over g. We can rewrite this one, ck minus g e raised to minus gx times e raised to ikx. That is equal to e raised to ikx times some function, that is we can call it as uk of x, where this uk of x is equal to summation over g ck minus g e raised to minus igx. Because uk of x is a Fourier series over the reciprocal lattice vector, it is invariant under crystal lattice translation T, so that uk of x is equal to uk of x plus t. This is what we discussed during the first postulate of Bloch's theorem. Now we are going to derive, we are going to show that this expression is correct. For that we substitute for x plus t in x, s plus t for x in the above expression, that is uk of x, so that the uk of x plus t becomes summation over g ck minus g e raised to minus ig dot x plus t. This can be rewrite as e raised to minus igt into summation over g ck minus g e raised to minus igx, that is equal to e raised to minus igt times uk of x from the above expression of uk of x. But we know that e raised to minus igt is equal to 1. That is quite common relations. G dot t e raised to minus ig dot t is equal to 1. It follows that uk of x is equal to uk of x plus t, and thereby establishing the periodicity of uk of x. This is called the alternate and the exact proof to the Bloch's theorem.